Hello dear students, wishing you all a very happy new year, and I hope that whatever things you have dreamed of, you must work really hard to achieve all of them, and this year brings you a lot of success, a lot of happiness and a lot of progress. Okay, so students, welcome to day 45 of PU2 Brahmastra series, our first class in 2025. So yes, I hope that you have a good break and you have done, and now it's time to really work hard. So in today's video we are going to do revision of all the formulas in the physical chemistry. Okay, I have taken all the 3 chapters and given you all the formulas. So what you have to do is to sit with a notebook and a pen and note down all the formulas that has been discussed here. Okay, so yes students, now let's get started without any further delay. First one is your chapter solutions. Okay, so in that we have first concentration terms formula, mass percentage, mass of the component in the solution divided by the total mass of the solution into 100. Okay, next volume percentage, volume of the component in the solution divided by the total volume of the solution into 100. So I am getting like aside from the screen, you can just take a screenshot of this or you can see properly and note down. Okay, so if you are writing it, so pause the video, just write down the formula, and now I'll be moving towards the next formula. Okay, next is your mass by volume percentage. So mass by volume is mass of the component in the solution divided by the total volume of the solution into 100. And the next one is parts per million. So number of parts of the component by the total number of parts into 10 to the power of 6. Okay, so I think this is visible. You can just take a screenshot here. Okay, and moving towards the next formula, that is mole fraction. So mole fraction is the number of moles of the component divided by the total number of mole of all the component. Okay, and here I want to add something. So mole fraction is denoted by the letter X. Okay, and if I want to write the formula for this one, then it is Na divided by Na plus Nb. Okay, now coming to molarity. So molarity is moles of the solute by volume of the solution in ml into 1000. Okay, and similarly if I have molality, so moles of the solute by mass of the solvent in gram into 1000. Moles you can, like, as it is W2 by N2, W2 by M2 is what? The number of moles of the solute. Okay, after completing 7 concentration terms, next formula is regarding your Henry's law. So Pg is equal to Kh into Xg. Okay, so I think this subscript superscript got mixed. It is like this: Pg is equal to Kh into X of G, right, where Pg is the pressure of the gas, X of the mole fraction of the gas, and Kh is the Henry's constant. Next, Raoult's law: P naught A XA plus P naught B XP. Okay, P total is equal to P naught A XA plus P naught B XP, where P naught A and P naught B are the pressures of the pure solvent A and B, Xa and Xb are the mole fractions of A and B. Next we have mole fraction in the vapor phase. Okay, so this is also very important. So Ya, okay, Ya is equal to Pa by P total. Okay, so Pa is the partial pressure of A and P total is the total pressure. Pa how we got? It is Xa dot P naught A, okay, divided by P total. So Ya is the mole fraction of A in the vapor phase. Similarly, Yb is the mole fraction of B in the vapor phase. Okay, next we have colligative properties. The first colligative property is relative lowering of vapor pressure. So P naught by P is equal to Xb, or delta P you can just expand it. Xb can be written as Nb plus Na plus Nb, but for very dilute solution this Nb can be ignored and we can get only Na. Okay, so delta P is P naught is the pressure of the pure solvent, P is the pressure of the solution divided by P naught. Okay, here it is P naught is equal to Xb, that is mole fraction of the solute. Okay, so one thing I can do here is, let me write down the terms, okay, so that we don't get confused. So I'll be writing all the terms here. Okay, so P is what? Pressure of the gas. Okay, I'll write also, you also write with me, pressure of the gas. Kh is what? Henry's constant. Okay, and Xg is equal to mole fraction of the gas. Okay, now Raoult's law, here we have P total, that is total pressure, Okay, and then we have P naught A and P naught B is the pressure of pure solvent A and B, pressure of pure solvent A and B. Okay, and what is XA and XB? These are the mole fraction of A and B. Okay, clear? Fine. Next, this we have already discussed. Here I want to again write. So what is P naught? P naught is the pressure of pure solvent. Okay, P is what? Pressure of solution. Okay, next XB is what? Mole fraction of solute. Okay, now this is the formula NB and Na. You can write down NB is number of moles of solute, and Na is number of moles of solvent. Okay, next coming to elevation in boiling point. So delta TB is equal to KB into M. Here KB is what? Elevation constant. Okay, elevation constant, and M is molality. Okay, so this formula is very important. So the molality can be expanded like W2 by M2 into 1000 by W1. Okay, so what are these terms? W2 is mass of solute, right? M2 is molar mass of solute. M2 is molar mass of solute. Then you have W1 is mass of solvent. Okay, clear? Okay, next this KB. Okay, KB you can calculate in a different way also. KB is equal to M1 into R into TB, sorry, yes, M1 into R into TB square divided by 1000 into delta H of vaporization. Okay, so what is this M1 here? M1 is the mass of, or I can say right, molar mass of solvent. Okay, R all of you know, this is gas constant. Okay, then delta TB is the boiling point. Okay, and we have delta H vaporization. Okay, next is your depression in freezing point. Same, delta TF is equal to KF into M. M is the molality. The sigmols carry the same meaning as I discussed there. And here also I can calculate KF in a different way. So that is your M1 into R into TF whole square divided by 1000 into delta H of fusion. Okay, here M1 is also the molar mass of the solvent. Next we have osmotic pressure, C into R into T. C is what? W2 by M2, number of moles into 1000 by volume of the solution in ml, into R into T. Okay, R is the gas constant, T is the temperature. Here you should be very careful, so I'll write R is the gas constant. Okay, T is temperature, and generally this temperature is taken in Kelvin. Okay, every time in calculation the temperature should be in Kelvin. Okay, next is Van 't Hoff factor. So Van 't Hoff factor formulas are there here. The I value, we have three formula: normal molar mass by abnormal molar mass, observed colligative property by calculated colligative property, number of particles after dissociation divided by the total number of particles before dissociation. Okay, now coming to I value for association and dissociation. So for dissociation, alpha is equal to I by 1, I minus 1 divided by n minus 1, and for association alpha is equal to I minus 1 divided by 1 by n minus 1, okay, where I is nothing but your Bandt factor. Okay, so alpha is the degree of dissociation, here alpha is the degree of association. Okay, so with this the formulas from the solutions chapters are done. Now let us move towards the next very important chapter, that is electrochemistry. Okay, so electrochemistry, first all of you will be knowing about Nernst equation. So there is a, suppose we have a reaction like this, Ni plus 2Ag plus gives Ni2 plus 2Ag. Okay, so if this is the reaction, then what will be the E naught value? So E of the cell is equal to E naught of the cell. So what is the formula for E naught of the cell? E naught of the cell is equal to E naught of cathode minus E naught of anode. Okay, so here how will you identify which is cathode or anode? So here oxidation is taking place, right? So always remember, anode is the one where what happens? Oxidation takes place, and cathode is the one where reduction takes place, right? So we have Ni2 plus oxidation and 2Ag plus 2Ag is reduction, right? So I can say that here nickel will be the anode, right? So which is anode according to the given example? Nickel, and silver is the cathode. So if I want to calculate E naught of this particular cell, okay, so that will be E naught of silver minus E naught of, okay, nickel. Done? Clear? Fine. Now if you see this one, if you want to write down, so product ions divided by the reactant ions. So product ion we have Ni2 plus, reactant we have Ag plus, and the square of Ag plus, and this n value is the number of electrons exchanged. Okay. Next, coming to equilibrium constant. So at equilibrium E of the cell will be 0. Okay, so now if you just see here this particular equation, E of the cell is 0, so I can write E naught of the cell is equal to plus 0.059 by n log of equilibrium constant will come here. Okay, so you can see E naught of the cell is equal to plus 0.059 by n log of k. Okay, that ratio became now a equilibrium constant. Okay, next coming to Gibbs free energy, we have two formula, delta G is equal to minus NF E naught of the cell, or delta G is equal to minus 2.303 RT log K, where K is again equilibrium constant. Here R is gas, R is equal to 8.314 joule, mole inverse, Kelvin inverse, T is your temperature in Kelvin. Okay, and K is equilibrium constant. Okay. Next we have Faraday's first law and Faraday's second law. Okay, so Faraday's first law, the formula is M is equal to Z into I into T. Okay, so where M is what? Here M is mass deposited. Okay, Z is what? Z is electrochemical equivalent. Electrochemical equivalent. I is what? Current, and time, T is time, and this is very important, the time should be in seconds. Okay, so now how to calculate Z? Z is equal to molar mass divided by N into 96500, where N is your number of electrons used or lost or gained. Next, Faraday's second law, M1 by M2 is equal to E1 by E2. So where E1, E represents equivalent mass, E represents equivalent mass. Okay, next, okay, so students, here is something for you all people. So as we all know that the new year is coming and our PU2 exams are also coming, so we have launched the PU2 Success Blueprint test series, where you will be getting 12 mock tests, which includes 4 part tests and 8 full length papers from the subject PC, MB and CS. Okay, now you will also be getting one shot revision videos, doubt clarification classes, and detailed video solutions, and PDF of the solutions will also be given. So now what you will be able to do with this test series is, if you purchase this, you can practice the questions and boost your preparation. Now this was available at 599 rupees. But yes, since new year is there, so we are giving you a discount on this, and the discount coupon you can use is NY2025 to get flat rupees 100 off. Okay, you will get rupees 100 off, and you can avail this as minus, like you will be able to get this at 499 rupees only. But remember, this this offer is valid only till January 10, 2025. Okay, so do not miss this opportunity and purchase the test series. So to get this, go to the description section, click on the link, and this test series is available for you. Okay. Okay, now we will go to some terms and symbols that I will be telling you. So resistance is R, okay, the units is ohm. Resistivity is rho, the unit is ohm meter. Okay, so then we have conductance, ohm centimeter or ohm meter. Conductance is G, it is inverse of resistance, so ohm inverse or S you can type. Conductivity is kappa, and kappa is resistivity inverse, so it is ohm inverse, meter inverse, so you can write S meter inverse or S centimeter inverse. Cell constant G star given by L by A, so it is meter inverse or centimeter inverse. Molar conductance lambda m, it is given by S centimeter square mole inverse or S meter square mole inverse. Okay. Now coming to the formulas for resistance, you know R is equal to rho into L by A. Okay, so rho is resistivity, L is length, A is area. Next we have resistivity, so rho, that's we can write RA by L. Okay. Then we have cell constant, that is L by A. Next we have conductance, so conductance is the opposite of resistance, right? So conductance is the opposite of resistance, 1 by R, and this one can be equal to A rho by L. I can write like this, A rho by L. Okay. Next we have conductivity, that is the opposite of this one, so conductivity, or you can write kappa, is equal to just the reverse of this one, so you will get L divided by A into R. Okay. Next we have molar conductivity, lambda m is equal to kappa into 1000 by C. Okay. Fine. Next coming to Kohlrausch law. So Kohlrausch law tells you that if a ionic conductance or a ionic electrolyte is there, then the total conductance of the electrolyte is due to the conductance of its cations and anions, right? So for example, if I want to calculate the conductance of NaCl, then that will be equal to the conductance of Na plus the conductance of Cl minus. If I have the conductance of MgCl2, okay, so that will be equal to conductance of Mg2 plus 2 times the conductance of Cl minus, because we have 2 chlorine here, right? Next, it is Kohlrausch law can be used to calculate alpha. So alpha formula is lambda m by lambda naught m. Okay, and using this alpha, so where this one is what, lambda m is what, molar conductivity. Okay, molar conductivity, and lambda naught m is limiting molar conductivity. Limiting molar conductivity. Okay. Now, if you once get this alpha, then you can easily calculate Ka. What is Ka? Ka is acid dissociation constant. Okay, so Ka is equal to C alpha square by 1 minus alpha. So in place of alpha, we can put lambda m by lambda naught m. So once you solve this, you will be getting this equation. Okay, fine. Next, so we are done with this Kohlrausch law, all formulas. So this chapter we have these formulas. There are a lot of theories. So to understand and so to make the theories more clarify, you can use the Decode NCERT series, where I have given you everything that you need to study from the chapter electrochemistry. And then if you want to revise the formula, you can do from here. You can go to Brahmastra series and watch all the questions and solve them. And if you want to do KCET questions, go to our KCET series. Okay, fine. Now coming to the last chapter, that is chemical kinetics of physical chemistry. So here what all formulas we have? First we have for zeroth order. Okay, so for zeroth order, the rate is equal to K. Okay, then integrated rate law is equal to KT is equal to A naught minus A, and the unit of K is equal to mole liter inverse second inverse. Okay, and there is a graph also you should be knowing for the zeroth order reaction. So the graph is done for this one, where you have y is equal to mx plus c. So A is equal to A naught minus KT. So A is here, okay, T is here, and we have minus K here. Okay, fine. Next we have the next topic, that is first order. So for first order, rate is equal to K into A. Okay, integrated rate law, KT is equal to 2.303 log A naught by A, where These terms I think all of you would be knowing, but still I will be mentioning. So we have what A naught is equal to initial concentration, A is equal to final concentration, okay, and K is equal to rate constant, okay, and T is equal to time, okay. That is done. Okay, now coming to the unit of K. So K unit is second inverse, okay, fine. Now we'll go to half-life method. So all of you know what is half-life, when the time taken for the reaction to complete to its half of its initial concentration, right. So T half is always proportional to A to the power of n minus 1, okay. Next, T half of 0th order and first order. So for 0th order the formula is A naught by 2K, and for the first order the formula is 0.693 by K. So where again A naught is your initial concentration, K is the rate constant, okay. Now we'll go to Arrhenius equation. So Arrhenius equation tells you how the rate of a reaction depends on the temperature, okay. So for that we have this formula, K is equal to A into e to the power of minus EA by RT. So I'll be explaining all the terms here. So K is your rate constant, okay. A is equal to Arrhenius factor, okay. EA is activation energy, okay. R is equal to gas constant, and T is equal to temperature. Clear? So these are the different formulas, the term explained here. Fine. Next we have this graph for activation energy. So you should be knowing how to draw this graph, okay. Next we have, okay, one second. So here some more formulas regarding the Arrhenius equation I will be telling you. So we got this one, right. So if I just go back, this is the Arrhenius equation, right, okay. So now this is there. So we have K is equal to A into e to the power of minus EA by RT. If you take log on both sides, so I will get log K is equal to log A, okay, minus EA by 2.303 R into T. So now if I draw a graph for this one, okay, so you will get log K and 1 by T, okay. Log A, then here you have the slope, that is EA by 2.303 R, okay, and here we have log of A, okay. Now if you are doing for two different temperatures, then the formula changes, and this is very important formula. Log of K2 by K1 is equal to EA by 2.303 R, okay, T2 minus T1 divided by T1 T2, okay. Now here what you should be knowing, K2 is what, rate constant at temperature T2, and K1 is equal to rate constant at temperature T1. Clear? And we have EA is the activation energy, okay. EA is the activation energy, and R is your gas constant. Okay, clear? Done? Fine. So yes students, that's all in this class, and I hope that you have revised all the formulas, and after this you can watch the Brahmastra series and solve the questions and revise it and do more question practice, okay. So thank you for watching, and see you soon in the next class.